Okay, if you listened, I gave a lecture about how to find the expected value of a function of a random variable, and actually I gave a very easy way how to do it. That's simply by plugging in the original. You got an x random variable, you got an fx, that's the function, that's a PDF. Just simply multiply, you take the y, that's the function of x, the new random variable, and you multiply it by the f of x, and then you integrate it. It's like a very nice and neat shortcut. But now I want to show you the long cut. It's good, it's nice to see how they both end up the same result. The long cut will be like this. First, we'll actually get the true PDF, a true PDF of this thing. So we start off again. X is a random variable that's uniform. It's evenly distributed from 0 to 1. So the f of x we all know is 1. That's it. Very simple. Next, y will be a function of x, and it's going to be x to the negative 0.8. That's what we used. I'm writing it down here. X is equal uniformly 0 to 1. Y is equal x to the negative 0.8. You see the top of the page. You see what we're doing here. Now, what we're interested is right now to find the PDF of y. So again, this can be done two ways. I'll do it one way. The way it works, the way how to memorize it is such a thing is called the g of x. That's the inverse. So I'll write it down first, and then you'll see how we carry it out. It's g f gx times gx. This is good to memorize this formula. F of gx times gx. The second gx is the derivative of gx, and the first one is f of gx. So let's see how to find both of these values. First of all, before we even start thinking, what is gx? Gx is the inverse that gets you from x to y. So how do you do that? How do you know what gets us from x to y? So the way to do it is we write down what you started off with. Y is equal to x negative 0.8. And start to think, how do you isolate? How do you get the x on one side of the function and the y on the other? So let's take this side that says x negative 8, and what we'll do here is, how do you get the x here by itself? So obviously 1 over negative see what I did here? I took this side and I multiplied it by negative 1 over 0.8. That turns it into x, because negative 0.8 times negative 1 over 0.8 is actually 1. And then I do the same thing to the other side. So you got on this side, you got y, making closer to the screen, you have to see you got here y to the power of negative 1 over 0.8. I do to both sides the same thing. Finally, we know that this is the gx here. It's actually, I should have written gy. Better if it used gy, because we're going to use the y is going to be here the value. So anyway, the gy is this y to the power of negative 1 over 0.8. Now, just to make it a little bit easier, should I leave it like this? It's 1 over 0.8 is like 1 over 8/10. That's 10 over 8. Let me leave it this way. I'll just leave it this way. I guess we can use the generic form of k. So it's y to the power of negative 1 over 0.8. Now how do we get the derivative of this? So we memorize the old method. You just deduct 1. So we deduct 1 from 1 over 0.8, you go down 1. That's minus, you take this 1 and you subtract 0.8 over 8. That's subtracting 1. Point 8 and you end up getting 0.2 over 0.8. Oh, I didn't do it right, I'm sorry. You must take this negative 1 over 0.8 and subtract 1 from it. That is the way to do it is 1 over 0.8 is 10 over 8. That's 5/4. That's negative 1.25. So it's negative 2.25. Let's go negative 1.8 over 0.8 is negative 2.25. Yeah, it's actually y negative 1.8 over 0.8, and then you multiply that by negative 1 over 0.8. this is the f. This is the f. The gy. The fgy obviously is 1 because the fx is 1, so nothing changes. This is just the derivative of the gy, and you use the absolute value, so you're left over with this thing here. So you put it in the box. Make sure you see this box well. That's the final answer after finding this thing. It's 1 over 0.8 times y negative 1.8 over 0.8. It's simply by finding the derivative of the inverse. That's it, what you need to do. You don't need to fool around with the fgy because it's simply 1. Now, we're not done yet. You see how long this takes. Now you need to multiply, you need to find the expected value. So you need to multiply this times y and then go through the whole thing from 1 to infinite. So let's first make it times y. So you actually are going up 1 level times y. So you just add now. So whatever you did before, you subtracted, you go back to where you started from. So simply you're just going up and down. This is quite easy actually, because we had already that we just made subtracted 1. So now we just add again a y. So we just erase this and we turn it back to the original way. That was simply negative 1 or 0.8. That's how negative 1 over 0.8. That's simply by undoing what we redid, because first by finding the derivative we were deducting 1 power of y. Now we're going it back, so this is quite easy actually. Now after this we integrate this thing here, this one. Okay, so by integrating this we erase again another, go up another level. So you add y negative 1 over 0.8 plus 0.8 over 0.8. That's already, if you do that, plus, so you have negative 1 over 0.8 plus 0.8 over 0.8. That's you adding 1. You end up with negative 2 over 0.8. That is a quarter actually, but I'll put it negative 2 over negative 0.2 over 0.8. That's negative a quarter. And we know the rule that whatever you got here, you divide that also by. So if it's negative a quarter, it's divided by a quarter. That's times 4. So that's what you got. The final analysis is, take a look here on the page. 4 divided by 0.8 times y to negative 0.2 over 0.8. That's really y to the negative a quarter. Now do this from infinite till 1, because that's the range where the whole thing spreads out. So if you insert the y infinite, you get infinite to the power of negative a quarter. That's like saying 1 over infinite to the quarter. Because that's negative a quarter. That's obviously 0. So it's 0 minus, now you put in the 1. So that's 1 to the power of anything is 1, and 4 divided by 0.8 is, so we know 0.8 means 8/10. 1 over 0.8 is 10 over 8. That's 1 1/4. 1 1/4 times 4 is 5. So here we made a long winded way. We got to the same result. We got to 5 after working for like almost 20 minutes. Basically, it's amazing that these two methods, get to the same result. Just this takes much longer. I just want to repeat the steps that we need to do here. This actually, I'm going to give you another next video on another method, and another method how to do it. There's like actually 4 methods how to get to the same answer. So the easiest method is the shortcut method. It's just using the idea that you just multiply the fx times the function that you get the transformation from x to y, and simply you just plug in the x, the g is equal, another g, I'm sorry, y is equal to x negative k. You plug that in and you do it from 1 to 0, and you're there, you're good to go. The second one is a lot of steps. First of all, you find the PDF of this new function, the transformed y. That's by using the rule of fgy times g prime y. Once you know that, you multiply this new thing times y, because that's already the expected value. You need to multiply by y. Then you go the integration from all the way this whole thing works. It works from infinite to 1, and finally you'll get this desired result. Now, the third video, I'll do the third way how to get this to the same result.